Good morning. In this class, we are discussing about DT-based servo motor. So, as we know that what is a motor? The main purpose of motor is to convert the electric energy. Electric energy is converted as a mechanical energy is converted of rotation motions. Okay. As we know that we have to know the stepper motor. So, what is the basic difference of stepper and servo motor? The stepper motor is nothing but is a control is an open loop. For example, what is the open loop? What supply you have to done given to your system is set started with certain RPM. Okay, but in the servo motor they have to analyze the input. What is the position? What is the torque? What is the angular velocity? Likewise, we have to use it for the servo motor is efficient manner, and also we have to apply the feedback signal of when it's your applied signal. Okay, so that is why the servo motor is more efficient when compared to the other motors. Now the students can be explaining what are the types and the advantage, disadvantage working of the servo motor. Yes.
Hello everyone, myself Hari Krishna. Today's topic is servo motor. A servo motor is highly specialized for electromechanical device that provides the precise control over angular and linear displacement, speed and torque. Unlike normal DC or AC motor, it just rotates continuously when powered. A servo motor operates under a closed loop control system, meaning it consistently adjusts its motion based on the feedback. There are some main parts of servo motor, which is a motor, DC or AC, which provides the motion of a motor, and control circuit receives the input command and control the power to the motor. Feedback device, encoder, resolver or potentiometer, which is used to monitor the actual position of the speed, and the speed. Error detector, compare the actual output with the desired input and corrects any error. Because of this feedback mechanism, servo motor can stop, start, reverse with high accuracy and repeatability, and makes the suitable for automation, robotics, CNC machineries and camera systems, antenna positioning, etc.
So now we'll see about the working of a servo motor. In this industry 4.2, these servo motors can be categorized into AC servos, DC servos and brushless motor. So basically this industrial servo motor has a specific working principle which it follows to work. So the first thing is the power supply. Generally 5 volt is sent for all the servo motors, even in the industries or hobby servo or motors used by children. So next is signal decoding, and here is where the signal sent is decoded and the message is sent to the motor which rotates, and then what happens is the feedback read. So how much angle and how much parameters is given, the output is read and the output is sent again. So then what happens is there is a thing called error calculation. Error calculation, it compares the given input and the output feedback. So it calculates the error and next it is sent to the controller. It is where often the controller or a PID controller is. PID controller, it turns the error into a steady state command or to control the magnitude of the motor, for example speed or angular velocity. And next the motor drive. The motor drive is generally D or H bridge is used to apply voltage or current to the motor, the DC motor or the brushless motor. And next is continuous feedback. In continuous feedback, as the shaft moves around, the feedback updates and the controller reduces the error. The error will shrink down. So and next finally hold or trim. Hold or trim is a process happens once the error is approximately equal to 0. So the controller issues a small corrections to hold the position against the load.
Motor. So there are basically 5 types of servo motor based on two categories: power supply and rotation. In power supply, the 2 types of servo motors are DC servo motor and AC servo motor. AC servo motor is basically used in high power industries and CNC systems due to its high efficiency and stability. And DC servo motor is usually used in small toys and small appliances used in houses for its very comfortable size and power supply. And if you are going for the rotation, there are three types of servo motor. Positional rotation servo motor, continuous rotation servo motor, and linear servo motor. So positional rotation servo motors are basically used for limited angle range, which ranges from 0 to 180 or 0 to 270, and continuous rotational servo motors are usually used for endless rotation in both direction. These are used in these motors are used in tires and mobile carriers. And finally, for the linear servo motors, it is used for transferring the rotational power into sliding power, usually used in slider systems and other things. So these are the types of servo motors.
Okay, today I am going to speak about advantages and disadvantages. First, servo motors are highly precious and accurate, which makes them suitable for application require exact position control. Second, they provide high torque at low speed, which is very useful in robotics and CNC automations. Now moving to disadvantages. First, servo motors are generally more expensive compared to other type of motors. Second, they often require a complex control system which increase cost and maintenance.
Thank you.